Hello students, my name is Teacher Tony, ready to take you through a comprehensive coverage of the topic atmosphere. I hope you are ready with your pen and notebook to note down important facts as we continue. What is atmosphere? Atmosphere is a thin layer of gases engulfing the Earth. This layer is held onto the Earth's surface by the Earth's gravitational force. That means the Earth moves along with it during rotation and revolution. The atmosphere has three basic characteristics. First, it is transparent, meaning we can see through it easily. It is also tasteless. And finally, it is odorless or fragrance-free. Let us now look at the structure of the atmosphere. There are four main zones of the atmosphere. The first one is troposphere, followed by stratosphere. The third one is mesosphere, and finally, thermosphere, which is also called the ionosphere. These zones are separated from each other by three zones of transition. The zones of transition, which are also known as isothermal layers, are tropopause, stratopause, and mesopause. Why do we call them isothermal layers? Because while crossing these zones, the temperature does not change. That means it is constant with the increase in altitude. This graph is an illustration of the main zones of the atmosphere with their various characteristics. We are going to look at each zone in details. Troposphere. This is the lowest level of the atmosphere that extends to a height of 8 kilometers at the poles and 13 kilometers around the equator. It is here that most of the weather-making constituents are contained. This is the only layer of the atmosphere in which living organisms, that is plants, animals, and people, live and breathe freely. Temperature decreases with the increase in altitude, which is referred to as a normal, positive, or environmental lapse rate. As you can remember during the study of weather, we learned that lapse rate is the rate at which temperature decreases with an increase in height above the sea level. We commonly say the higher you go, the cooler it becomes. The speed of wind is also seen to increase as one rises higher. On the contrary, the atmospheric pressure and the effect of gravity fall with increase in height. The troposphere contains most of the atmospheric water vapor, clouds, dust particles, and some pollutants. Between the troposphere and the stratosphere, there is a zone of discontinuity known as tropopause. This zone rises up to 18 kilometers at the equator and 9 kilometers at temperate regions. The zone experiences zero lapse rate. What does that mean? That there is no change in temperature across the zone. In other words, the temperature is constant with the increase in altitude. The stratosphere is the layer of the atmosphere that is above tropopause. It extends to a height of 30 kilometers from the surface of the Earth. The layer contains very little dust and water vapor. There are no clouds at all. Unlike in the troposphere, the temperature in the stratosphere increases with the increase in height. This behavior is referred to as negative lapse rate. Also contained in the stratosphere is the ozone gas. The gas absorbs ultraviolet radiation from the sun. These are light wavelengths that make exposed skin to be darker, also responsible for causing skin cancer. Winds are generally light, but their speed increases with altitude. Here, the atmospheric pressure continues to fall. Why? because the air is very dry and therefore it is less dense. Most significantly, the stratosphere is the protective shield against meteorites. They usually burn out as they enter the Earth's gravitational field. Between the stratosphere and the mesosphere, there exists a zone of discontinuity known as the stratopause. It lies between 30 kilometers and 40 kilometers. The temperature is constant, hence zero lapse rate. Right above the stratopause lies a massive zone called mesosphere. This zone extends from 50 kilometers to 80 kilometers above the Earth's surface. Temperature decreases with increase in height, with the lowest temperature of negative 90 degrees Celsius. This means that this zone experiences a positive lapse rate, just like in the troposphere. The zone is deficient in water vapor, dust particles, and ozone gas to absorb the incoming radiation. It also experiences very strong winds of about 3,000 kilometers per hour. Mesopause is the zone of discontinuity separating the mesosphere and the thermosphere. Just like other zones of discontinuity, it experiences zero lapse rate. Now let us look at the thermosphere, or also referred to as ionosphere. This is the uppermost layer of the atmosphere that extends from 90 kilometers to 120 kilometers above the surface of the Earth. It contains the electrons and ions that influence radio waves. Here, the atmospheric gases are ionized by becoming solar radiation. The temperature increases rapidly with increasing height, reaching 1,500 degrees Celsius. This means that it experiences negative lapse rate. The high temperature is due to the increasing proportion of atomic oxygen, which absorbs short ultraviolet radiation from the sun. Having looked at the zones of the atmosphere, we now proceed on to look at the composition of the atmosphere. Despite the fact that the atmosphere is colorless, tasteless, and odorless, it has quite a number of components. These are the air, water, vapor, dust, ozone layer, and pollutants. Let us look at each one of them in details and as well as featuring their significance. Air. As you know, air is a mixture of gases. Examples of these gases are nitrogen, oxygen, carbon dioxide, and rare gases. Nitrogen consists of 78% of the total air found in the atmosphere. It is used in a number of ways, such as manufacture of fertilizers, explosives, and ammonia gas. Oxygen is a colorless, odorless element that is the most abundant element, constituting of up to 21% of the total air in the atmosphere. It is very essential for breathing, forming of compounds with other elements, respiration in animals and plants, as well as supporting combustion. Carbon dioxide is a colorless, odorless gas that originates from respiration and combustion. It constitutes up to 0.03% of the total air found in the atmosphere. Carbon dioxide is useful during photosynthesis as a raw material, also used in refrigeration, preservation of carbonated drinks, and in fire extinguishers. Let us look at the rare gases. Rare gases are also referred to as inert or noble gases. They constitute 0.94% of the total air contained in the atmosphere. Examples of rare gases are argon, neon, xenon, helium, and krypton. Water vapor. This is also referred to as moisture. Water vapor contains a total of 1% of the total gas found in the atmosphere. It is very essential for cloud formation and precipitation. It helps in absorption and reflection of the incoming radiation. Let us look at dust. Moving air, commonly known as wind, blows very small, dry, and consolidated particles of the substances such as soil and coal from the Earth's surface. Similarly, during a volcanic eruption, there is a massive production of the said dry particles suspended in the air in form of cloud. This is referred to as dust. Dust is very useful during the formation of clouds as it acts as condensation nuclei. It also absorbs and reflects the incoming solar radiation, hence playing a crucial role in regulation of the atmospheric temperatures. The next component of the atmosphere is ozone layer. I want to believe it is not your first time to hear of ozone layer. As mentioned earlier, this is a layer which is rich in ozone gas that helps absorb ultraviolet radiation. Studies show that ultraviolet radiation can cause skin cancer, cataracts of the eye, and also suppress the immune system of the body. Organisms such as fish, crabs, amphibians, and other animals that live in or around water, including phytoplanktons and microscopic organisms that form the foundation of aquatic food webs, are all at risk from this. Ozone layer is at risk of damage by chlorofluorocarbons, commonly known as CFCs. When CFCs escape from sources such as the air conditioners, refrigerants, heat pumps, and aerosol propellants, they drift up to the stratosphere, where strong ultraviolet radiation from the sun breaks them down. The breaking down releases chlorine, which depletes the protective ozone layer. Note that one single chlorine atom can destroy over 100,000 ozone molecules. Perpetual depletion of the ozone has resulted into what is commonly referred to as global warming. The last component of the atmosphere is pollutants. These are waste products that contaminate the air. Examples of atmospheric pollutants are sulfur dioxide, nitrogen oxide, and methane gas. Pollutants are commonly released from industries, power stations, car exhausts, and volcanic eruptions. Atmospheric pollutants are responsible for the formation of acid rain, which is potentially harmful to the environment. Sulfur dioxide reacts with moisture, forming a shiny substance that reflects back the solar radiation. Hence, it is responsible for the regulation of the atmospheric temperatures. Student, that marks the end of our coverage of this topic, atmosphere. I hope you enjoyed the presentation. Thank you.